We are going to finish off our lesson from the last, or our note from the last lesson, examples number 4 and 5. And hopefully you've had some practice with this, getting a little bit more familiar with our special triangles, our angles in standard form. So this time we want to take a look at these, and we're going to be talking about these measures in radians. So first thing we want to do is find out what the ratio is that we're going to be using. So we want to isolate tan to figure out what our ratio is. So first thing we're going to do is take our 1 over to the other side, and then we're going to divide both sides by √3. So we now know what tan ratio we're looking for, and notice we want an exact answer, so this does have to be one of our special triangles. Well, we know that it's not our 45, 45, 90 because we're talking about √3. And 45, 45, 90 is 1, 1, √2, which means that we're going to be talking about 30, which is pi over 6 as radians, and 60, which is pi over 3 in radians. So we're going to have 1, 2, √3. Tangent is opposite over adjacent. So opposite being 1 has to be from our pi over 6. So our related acute angle from our special triangle has to be pi over 6. Okay, tan, we know our ratio was positive, so tan is positive in, if we think about our cast rule, tan is positive in quadrant 1 and 3. So quadrant 1, x is our acute angle that we already figured out, pi over 6. In quadrant 3, it's going to be pi over 6 past the 180. So x is going to be equal to pi, which is 180, plus our pi over 6, 6 pi over 6, getting a common denominator, plus pi over 6 gives us 7 pi over 6, which means that, again, we have two solutions, pi over 6 or 7 pi over 6. Second one, again, first thing we're going to do is isolate cos x so that we know what the ratio is. First thing we're going to do is multiply out to get rid of our brackets. Remember, multiplication comes before adding, so we're going to get rid of our brackets over here first. Then we're going to collect like terms, just like we do any solving equations question. So 7 cos x, bringing our 3 cos x over. We had 13 plus 24 already here. We're going to subtract 35. So 4 cos x equals 2. So cos x is equal to 1/2. 2 divided by 4, simplifying, we get 1/2. Now, thinking about our special triangles, we do have a special triangle. If we're not sure, we can draw them both to see where we get our 1 over 2. But remember that 1, 2, √3, so we're going to have our pi over 6, pi over 3, so 30 is 1, 2, √3. So adjacent has to be the 1, which means we're talking about pi over 3. So our related acute angle from our special triangle is pi over 3. We look at the sign of cosine is positive, so cos is positive in quadrant 1. And again, cast rule means quadrant 4 is our other positive value for cosine. So quadrant 1, we have pi over 3. Now notice though that our question tells us to find it to 2 decimal places. So we can just take pi button, divided by 3, and we get 1.05 radians. And again, we are going to put RAD in there because we want to make sure we're not talking about degrees. Now, quadrant 4, we're going to be 2 pi minus our pi over 3. So 12 pi over, 6 pi over 3, because we're going to multiply top and bottom. So 6 pi over 3 minus pi over 3 means we get 5 pi over 3. Again, putting this into our calculators, 5 times pi divided by 3 gives us approximately 5.23 radians. So again, 2 possibilities, x is 1.05 and 5.23 radians. Okay, so again, same thought processes go behind this. It's just that we're talking about our full rotation in radians. Okay, so a few more questions to practice from last day's worksheet, and